Welcome to Global Nexus. Please subscribe and hit the bell icon for more breaking updates. It began as a faint smudge on a digital screen. On July 1, 2025, deep in the Chilean mountains, the Atlas telescope was scanning the sky for threats to Earth. But that night it found something extraordinary. An object moving too fast, on a path too steep to belong to our solar system. The software flagged it immediately. This was no ordinary asteroid, it was a visitor from interstellar space, a cosmic tourist just passing through. News spread rapidly among astronomers. Telescopes worldwide turned to track this mysterious object. The data was clear. The object, soon named 3I Atlas, was on a hyperbolic orbit, proof it came from beyond our sun. Only two such objects had ever been seen before. Oumuamua in 2017 and 2I Borisov in 2019. Now a third had arrived, and it promised to be the most spectacular yet. 3I Atlas was a fleeting guest, destined to swing around the sun and vanish forever. Scientists had only a brief window to study it and unlock its secrets. The public was captivated, and a little uneasy. Headlines buzzed with talk of a mysterious object from deep space. Was it dangerous? NASA quickly reassured everyone 3I Atlas would pass at a safe distance, about 170 million miles away. No threat, but a profound reminder. Our solar system is not an isolated island. Sometimes things from the wider galaxy wash up on our cosmic shore. This was a rare chance to study a true interstellar messenger. What secrets would it reveal about worlds beyond our own? The race was on to find out. For scientists and the public alike, 3I Atlas was a symbol of cosmic connection. The universe had sent us a visitor, and we were ready to listen. What exactly is an interstellar object? Simply put, it's a wanderer between the stars. These are comets or asteroids not bound to any star, drifting freely through the galaxy. Most were likely ejected from distant solar systems during their chaotic formation. For billions of years, they travel the cold, dark void, until by chance, they pass through ours. Interstellar objects are scientific gold mines, free samples from other star systems. We can't visit other stars, but these objects bring pieces of their home systems to us. By studying their composition, we learn if other solar systems are made of the same stuff as ours. Oumuamua was a puzzle, small, oddly shaped, and unlike any comet we'd seen. 2I Borisov looked more familiar, suggesting some comets across the galaxy might be similar to ours. Each new visitor is a time capsule, a clue to how star systems form and evolve. Finding them is incredibly difficult. Space is vast, and these objects are tiny and fast. Only with new survey telescopes like Atlas and the Vera C. Rubin Observatory have we begun to spot them. These powerful instruments scan the sky every night, catching faint travelers as they pass by. Interstellar objects are rare, but now, we finally have the tools to find and study them. Each one brings us closer to understanding our place in the galaxy. When detailed measurements of 3I Atlas arrived, astronomers were stunned. Its speed was astonishing, 130,000 miles per hour, faster than any known interstellar object. No object orbiting our sun could move so quickly. It was a true cosmic cannonball. Its size was even more impressive. Estimates ranged from 1,000 feet to over 3 miles across, much larger than Oumuamua. This made it a bright, substantial target for study. As it neared the sun, it released gas and dust, giving scientists plenty to analyze. Most intriguing was its possible age. Models suggested it could be older than 7.6 billion years. That's billions of years before our solar system even formed. 3I Atlas could be a relic from a long-lost star system, a witness to a different era of the galaxy. Its speed, size, and age made it a scientific treasure. It challenged our models and raised new questions. How was it ejected? What kind of system produced it? 3I Atlas wasn't just another comet. It was an extreme, ancient outlier. And it was here, offering us a glimpse into the galaxy's distant past. Once 3I Atlas was spotted, astronomers worldwide sprang into action. The Hubble Space Telescope captured a clear image, revealing a bright nucleus and a classic cometary tail. The James Webb Space Telescope analyzed its light, searching for chemical fingerprints, water, carbon monoxide, methane. Mars orbiters and even surface rovers caught glimpses as the comet passed by the red planet. The most critical moment came at perihelion, its closest approach to the sun, when it was most active. For weeks, it disappeared behind the sun, invisible from Earth. When it re-emerged, Observations resumed, tracking its outbound journey. Next, it would pass by Jupiter, then vanish into the darkness. This global campaign used every tool available: space telescopes, ground observatories, even planetary probes. Each observation added a piece to the puzzle. The world's scientists worked together, determined not to waste a moment of this rare encounter. 3. Atlas was a fleeting visitor, but the data it left behind would last for generations. Humanity had risen to the challenge, capturing a cosmic event in real time. Whenever a strange object appears, the question arises: could it be aliens? Harvard's Avi Loeb suggested 3I Atlas might be an alien probe, citing its odd trajectory and timing. The idea spread quickly, fueling headlines and speculation, but NASA and most scientists saw no evidence for anything artificial. Hubble's images showed a classic comet, and Webb's data revealed only natural molecules, no technology, no signals. The scientific consensus was clear: 3I Atlas was a comet, not a spacecraft. The real excitement was the chance to study a pristine object from another star system. Extraordinary claims require extraordinary evidence, and none was found. The alien theory made for great stories, but the truth was just as thrilling. 3. Atlas was a natural wonder, not an artificial one. The universe had sent us a message in ice and dust, not metal and code. Sometimes, reality is more amazing than fiction. The study of 3I Atlas was a global effort. Astronomers everywhere coordinated to track its journey. Telescopes in Chile, Hawaii, Spain and Arizona worked in shifts, ensuring continuous coverage. Space-based observatories like Hubble, Webb, TESS, and Swift joined in, each revealing different details. Even spacecraft on other missions, like Lucy and Europa Clipper, turned their instruments toward the visitor. The goal: gather data across the spectrum, visible, infrared, ultraviolet, to decode its secrets. Every observation was a piece of a cosmic puzzle. By analyzing its ices and dust, scientists hoped to learn about the star system it came from. Was it similar to our own, or something entirely different? The campaign was unprecedented, a true all-hands-on-deck moment for planetary science. Each photon collected brought us closer to understanding the galaxy's diversity. 3I Atlas united the world's scientists in a shared quest for knowledge. Its brief visit left a legacy of discovery. The flyby of 3I Atlas marks a turning point in astronomy. For centuries, we studied only our own solar system. Now, the era of interstellar studies has begun. Improved technology, like the Vera C. Rubin Observatory, means we'll soon find many more interstellar visitors. What was once a once-in-a-lifetime discovery will become routine. With each new object, we'll build a catalog, revealing patterns and diversity across the galaxy. We'll finally answer: is our solar system typical or unique? 3I Atlas is speeding away, but its legacy is just beginning. It inspired scientists and the public, proving we can mobilize globally for fleeting cosmic events. The universe has sent us a message, and we're ready to read it. The search for the next visitor is already underway. Each new discovery will bring us closer to understanding our place in the cosmos. The sky is waiting, and we are watching.